Now we're ready to find the critical path through the network diagram. If an activity has zero float, which means there is no difference between the earliest event time and the latest event time, that means it is on the critical path, because if it starts any later, it will finish late and the project as a whole will finish late. So, starting at the beginning, we can see that the earliest and the latest event time for activity A both 0, which means A is on the critical path. So we're going to highlight that particular arrow. Now we come to the junction. If we look at activity B, we can see that the node before has 2 for the earliest and 2 for the latest event time. But we know from our calculations that the real latest event time for activity B is 3. So activity B is not on the critical path. Activity C also has 2 and 2 as the earliest and latest event times, but we know from our calculation that the real latest event time for activity C is 4, so that is not on the critical path. We now look at the final path through the bottom part of the diagram, and the earliest and latest event time for activity D are both 2. So there is no spare time here, so activity D is on the critical path, and we highlight that arrow. We now look at activity H. The start time for the earliest and latest for activity H is 5. That means there's no float, that means it's on the critical path, so we highlight that arrow as well. We come to activity I as the next activity. The earliest and latest event time are both 12, there is no spare capacity, so we know that activity I as well is on the critical path, so we highlight that activity too. We now have the critical path A, D, H. This is the longest path through the network in terms of time. Although there are fewer activities, it takes longer to go from A to D to H to I than any other sequence of activities through the network. And if there is any delay on any of these activities, the whole project will run late. However, if there is a delay on B, E, F, C or G, providing it is within the float, that's the spare time, the difference between the earliest and latest event time, that will not cause the project to run late. So we could start an activity a bit later, finish a bit later, or just take a bit longer without the risk of the project overrunning. Also note that the critical path must go the whole way through the network. It would be wrong to say that activity B was on the critical path because the subsequent activities E and F are not. The critical path must go from the first node of the network through one or more sequence of activities before reaching the final node. There could be more than one critical path through the network.